Hello, my name's Anne Bogle. I'm a soil scientist at ADAS, and I'm going to introduce to you today the cultivations trial that we're working on with Rob Fox at the Strategic Farm West. So the aim of this trial is to determine the impact of cultivation depth on soil properties, crop rooting, yield and gross margins. It was started in the very first year of the strategic farm and will continue for the full 6 years. So in autumn 2018, 3 different cultivation depths were compared along full tramline lengths, replicated twice across the field, as shown in this diagram here. So 5 centimetres depth, 15 and 30 centimetres depth. Then in autumn 2019, another treatment was introduced so that we can compare the different cultivation depths with no cultivation, so with direct drilling. Again, replicated twice. So in 2018, winter wheat was grown, and last autumn oilseed rape was drilled, but unfortunately it didn't establish very well. And so in early January, it was sprayed off and spring beans were subsequently established. So we're doing a number of assessments each year on the trial. At the outset, we looked at soil chemistry just to get a baseline assessment of what was in the soil. And then on an annual basis, we're looking at soil structure in terms of visual assessment, penetration resistance, bulk density, and we're also counting earthworms. And this chart here just shows the penetration resistance profile that we got last spring. And it clearly shows some differences between the different cultivations. So in the topsoil, the shallow cultivation had a higher strength than the other cultivation treatments. And this swapped over as you went down the profile. So below 30 centimetres, it was the deeper cultivation that had the higher resistances. And then alongside this, we're measuring crop rooting, particularly using a shovelomics technique, which looks at root growth and root architecture in the spring. And then we're looking at crop biomass and crop yields. So in terms of crop yields, we're using Rob's yield map and the ADAS agronomics program to see if the treatments are having any effect and to be able to take account of also any underlying spatial variability. And last year we saw no significant differences in yield due to the different cultivations, although yields were marginally higher on Rob's standard cultivation, which was 15 centimetres depth. Now the beauty and the value of this experiment is that it's continuing for the remaining 4 years of the Strategic Farm Programme. So we will be able to look at the longer term effects of these different cultivation strategies. Thank you.
Hello, my name's Frances Pickering and I'm an entomologist at ADAS. Today I'm going to talk you through a cultivation demonstration at Strategic Farm West. Specifically, how do different cultivation techniques impact cabbage stem flea beetle? So why do we care about cabbage stem flea beetle? Well, they're a major oilseed rape pest within the UK, and they're an increasing problem due to the lack of chemical controls. And also, in recent years, the weather conditions have been ideal for the reproduction and survival of this pest. Therefore, there's an increased importance of cultural control. This trial was a replicated tram trial. It was a single field divided into 4 pre-drilling treatments. This included direct drill and cultivations at 5, 10 and 15 centimetres. We measured plant establishment, adult feeding damage and larval pressure. Now let's look at some results, starting with crop establishment and size. We found poorer plant establishment and fewer plants were found in treatments with deep cultivations compared to shallow cultivation and direct drill. In fact, by November, there was a noticeable difference in crop size. If you look at the picture to the left, you'll see that the 30 centimetre cultivated plant is much smaller than the direct drilled plant to the right. The reason for this is unknown, but it's likely to be due to the dry weather conditions found at the time of drilling. Now let's look at some adult damage. In this graph, you'll see the different treatments along the x-axis and the adult damage as % leaf area lost on the y. What you can see is that in the cultivation treatments, there's higher adult damage found than in the direct drill, but it's important to note that these are not statistically significant. What this means is that the cabbage stem flea beetle aren't necessarily eating the smaller plants, but the plants are tending to grow slower, and so they do not grow quick enough to compensate for the adult feeding. Also, on smaller plants, the same level of adult feeding can appear to be more pronounced than on larger plants. Now let's look at the larvae data. We measured the larvae in both November and January, but we found the same trends. We found that significantly lower number of larvae were found in deep cultivation treatments compared to the direct drill and 5 centimetre. This is because it may be possible that the adults are preferentially laying under the base of larger plants and then hatching and resulting in a higher larval pressure than in direct drill or in the shallow cultivation treatments. Alternatively, smaller plants just might not be able to support as many larvae as the large plants. But it's important to note at this point that the relationship between larvae and yield is poorly understood. In fact, these small plants at the deep cultivations may have yielded poorly despite the low number of larvae seen here. Now to conclude, at deep cultivations, we see poorer plant establishment and fewer plants. We also saw more adult damage, although this was not significant. And finally, we saw significantly less larvae at deep cultivations. We think these results are driven by the size of the plants. It's important, therefore, to use a pre-drilling method in which allows you good establishment of your crop. Thank you.
Hi, I'm Rob Fox. I am the AHDB Strategic Arable Farmer for the West region, farming about 1,000 acres of combinable crops just outside Leamington Spa in Warwickshire. I'm here in our establishment trial field where we've been working the ground to different depths and seeing what impact that has on the crop. Hopefully it's one of our longer term trials and we'll be running it through the full 6 years of the Strategic Farm programme. Year one, this was in winter wheat last year in effect, and we saw very little difference on the difference in these in the depth that we moved the soil in front of that crop. It was a dream autumn and winter. It was a very dry year for us, a very dry winter for us, so that had very little effect on the final yield of the crop. This autumn, this was supposed to go into oilseed rape. In fact, it did go into oilseed rape, and it was very difficult from day one. It was very, very dry when we drilled. Then obviously it came very, very wet in September, and with the added pressure of flea beetle, we struggled to keep the rape alive. It still let us have some very valuable data back where we direct drilled or very shallow disked and then drilled. The rape actually established and started to get away quite well, but then the wet winter meant that it couldn't get its root down as the soil hadn't been moved at any great depth, and that started to give up. Conversely, where we worked the ground a lot deeper, it dried out a lot. August and early September were very, very dry for us, and that part of the crop, that part of the trial didn't establish well at all. So unfortunately we had to take the decision to write off this crop and decide on what to do with it in the spring. We have managed to get it established with spring beans this autumn, as you can see behind me. This spring. And the whole field is established. It started to grow away. It's now very, very dry and suffering for very different reasons. But we can already see some differences in the trial plots. and the beans, the plants behaving very differently at different depths. So this one will be really interesting. We'll obviously go through to harvest again. This will all be mapped with the combine, and we'll be able to get an idea of where there's differences in yield, or whether they're just visual differences as we go through the year.